Hello, everybody. My name is Adi Rosenberg. I'm happy to be here again. And today I'm going to talk about something that really excites me because I hope it will make some dent in the industry. I'm talking about something new that we call delivery performance score that I would like the industry to adopt. So let's start with why do we need that? In my previous presentation, I showed you that in my company, we can do precise measurement and provide a lot of information about the network KPIs and ability and detect jitter, latency, packet loss things. But in order to analyze that, you need to have a lot of knowledge, and that knowledge is today is belong to a small group of people, mainly architects and professionals. And we thought that we need to change that paradigm and provide a score. So this presentation is going to touch base on that. So we need to understand that the basic is that not all networks are born the same. The internet was designed for general data application with, with asymmetric upload and download speeds and performance, but high reroutes, error rate, and jitter are prone to the internet. MPLS is a super lane over a network with SLA and QoS to allow better user trust in resource allocation over time, with the service providers to address issues that come up with the MPLS, so you have somebody to call if there is a problem. Dedicated circuits are there to provide private lanes in the network, just like MPLS, but at better QoS and SLA. The same goes for public cloud. It includes ingress and egress challenges, but also internal traffic is sometimes challenging to connect services, AMIs, availability zone, and so on. And we have the mobile network. 5G is now running, moving forward to provide delivery of video over multitude of segments. So, some questions that we need to address. How do we know if the network will fit our intended application? How do we know if the network is misbehaving or the trend is worsening? What type of delivery protocol to use to achieve for our goal? How do I monitor my delivery without becoming a super expert like myself in the fine details of delivery? How do we train our technical staff to keep up with technology advances? The answer for that is that it's hard, it's tough. So let's start with some examples. We see here a route and a routing, and we see RTT. So in order to understand that, you need to have certification, IT certification, whether that's Cisco, Juniper, have a college degree to understand what is going on and should I react to that. If you are expert, you will study, you will learn, and you will master this. But if you are an operator or engineering manager, you forgot all of that 10 years ago. It's too complicated for you to come to remember that and know what to do with that. The same is true with this ECG type of graph that shows a lot of problems that are happening on the network. And now I need to guesstimate what will the outcome of this and how it will impact my network or my performance, my application. I need to be on top of that. And we thought that this is somewhat problematic. So the question is, what is missing? Organization spends money on training and education to learn each KPI and its impact. How does jitter impact my delivery? Will jitter cause problems if I'm doing 2110? If I'm doing SRT, I need to understand what are the limitations of SRT. A user needs to have the ability to know and master all the aspects of the network KPI to understand how his delivery may behave. We therefore need an easier way to understand the network across different organizations and technical departments. We need a simpler decision support mechanism. Today, each decision is based on multiple KPIs that are hard to master. So what is the solution? We want to introduce the delivery performance score. To those who remember the good old days, the MDI, the Media Delivery Index, which was good for some people, but it did not look into many KPIs and the sampling rate was very low. Instead, we suggest to have something new with the following objectives. A simple number that can accumulate multiple real-time statistics, aka KPIs, in one formula. Define regions, green, orange, and red areas. Green, the network is in proper operational conditions. Orange, one or more network KPIs is below proper conditions. And red, one or more network KPIs is performing badly and must be addressed immediately. The score needs to address different delivery and performance objectives, meaning that a score for SRT will have a different KPIs or different weights or read areas of decision making versus uncompressed workflow like 2110. We want to allow simple events and alarm creation for simpler logic and decision making. We want users to define weights for them to define what are the end areas that interest them. And we want to allow the user to set values and points and weights. To better understand that, let's look at different protocols and parameters. For instance, if you want to run a low latency ARQ, let's say with ZigZee, SRT, whatever, you will not allow more than 10 milliseconds of jitter. The error rate that you will probably allow is no more than 4%. Latency will be at most 20 milliseconds and RTT maybe 40 milliseconds, and you will want high availability of the connection. But if you are running a standard SRT, you will allow like 30 milliseconds of jitter, an error rate of, let's say, 10% packet loss. The latency can crank up to 50 milliseconds, the RTT to 100, and the availability is high. On the other hand, if you are using low latency, light compressed flow, you will allow only maybe 20 milliseconds of jitter, latency of 40 milliseconds, but everything else must be zeroed because we will not tolerate any packet loss and we don't care about RTT. If we in fact do in production and we want to have the best solution, we will not tolerate more than 4 milliseconds of jitter, zero packet loss, latency of no more than 6 milliseconds, because we need to hit that 60 millisecond mark for the delivery. So that is challenging, but that is how we will grade the performance of the network based on these KPIs. So we sought out to find a formula, a way to express this. To define an area which is green, and we wanted to do a score between 100 to 0. 100 is the best conditions, 0 is the worst. So we said green will be 100 to 90, and orange will be between, it should be less than 90 and higher than 80. Red will be anything less than 80. So we tried to avoid lookup tables, so it will be easier to implement in software. We said that we need to have, each KPI need to have a different value range based on what we decide. And we wanted to create a weighted formula based on the KPIs. Then we said, let's test the outcome against subjective industry values and experience from rule of thumbs and how experience that we drew from our past knowledge. And I've been in this industry for more than 30 years. So we started with a simple approach. We created those lookup tables. We basically went and graded every KPI, every thing that we can think about. We gave it a number, a score. Then we used ChatGPT. We gave ChatGPT the fun of crunching the numbers and finding us the best suitable formula to meet those lookup tables. And ChatGPT came with an answer. And this is the formula that we see on the left. And then we basically tested that against what we think is good, and we also run that in live tests, in live environments. So what we can see is that the green is the area between 100 to 90. The orange starts at 90, give us about 80, it's between 81 to 80.1. And then the red gives us, with this formula, 80 to 20. Anything beyond that, it's like run to the hills, nobody cares. For the formula, we then weighted each KPIs for the target applications. So let me show you how the outcome looks like. So we have real-time precise monitoring, and now we see the KPI on top. And you can see that the KPI we gave, in this case, this is an SRT workflow. And what you can see is that it follows the error rate. The error rate is much more weighted than other parameters, but some are there also impacted by jitter, latency changes, and RTT that you can see on the left. So suddenly we have a single number, a single score that we can monitor. We don't need to understand the ECG. We can have an operator, high school graduate, somebody that doesn't understand video, look at the score and see if I'm in the green or above 90, everything is A-OK. So let's see that. So for instance, 86, something is brewing. The error rate jumped. You need to make a note of that. Another event, we have 87. Well, problematic as usual, but deep depression, high spike of packet loss, beyond traditional. SRT will not be able to tolerate that. We need to make a note of that. That will cause problems. But we do not, the operator doesn't need to understand, doesn't need to have a degree to understand all the below. So it's easier to maintain. Suddenly, it's color-coded. Based on the colors, I can understand the health of my network. I can understand the health of my route. And if everything is green, I can have a cup of joe. That's it. I don't need to look of anything. All I need to do is that I have an architect or somebody experienced dialing the limitation of the parameters, of the KPIs, and it will formulate the number that I need to monitor and track. And that's it. I can create a report, send to my management. Everything was green over the weekend. I'm doing the Super Bowl. Everything is green. I had an event at 5:45. It jumped to an orange. We may expect some hits, but it might be very small. But if it's red, well, I need to take a note into that. If I'm wanting to look onto the network, I can look at what is green, what is red, so I now know how my links look like. So what is next? Now we have an easier one score to master. Broadcast and IT can evaluate the same score. IT doesn't need to understand jitter packet loss. Actually, they do, but they need to understand just the score. I don't need to talk about I have jitter. Just to say the network is below the bar that we set up, that's it. They need to act upon that. Non-technical people have a simple indicator. Management can easily evaluate its operation because if everything is in the green, hey, we are good to go. Nothing should worry us. Each protocol delivery protocol has its own regions with common score system, meaning that I can evaluate different protocols on the given network, giving up the same scores. Another benefit is easier alarming because now I have one value to monitor to understand how the network is behaving. I can then bring the expert to look what is the root cause of that, but I have only one alarm to use. And it makes decision making much more simpler to run out automation and so on. Questions, anybody?